Pleasure for me to speak in these walls about the discovery which usually lasts 200 years is called Seebeck effect, the thermoelectricity. But actually it was discovered here in Pavia and by the first president of our academy, Alessandro Volta. So I will start from the history. So outline is that fascinating history of thermoelectric and thermomagnetic phenomena, thermodynamic approach to thermoelectric effects, manifestation of thermoelectricity in metals and semiconductors, a giant manifestation of Seebeck and Nernst effect, figure of merit, problems of modern applications, and new materials for thermoelectricity. So, end of 18th century. Electricity is known as some kind of divertisement in the kings and noble society, etc. So it is completely descriptive. No one still knows about the essence of electricity. And professor of physiology of Bologna University, Luigi Galvani, makes his famous experiments with frogs' muscles. He studies the behavior of frog muscles in different conditions, in the thunderstorm, etc. But the most characteristic here experiment was that he took the fresh muscle of a frog and connected its extremes with the bimetallic arc. And he found convulsions. So it was 1789. In 1791, the colleagues of Alessandro Volta in Pavia University attracted his attention to experiments of Galvani. But he was a physicist and he did not pay too much. He was pessimistic about this. But he repeated these experiments and he found that indeed there are convulsions. So in his letter, which you can find here in our archive, he writes to Galvani, "Dear Galvani," it was a letter from the May 5th of 1792. He writes, "Dear Galvani, you have succeeded to transform me from the deep pessimistic to very enthusiastic optimist. I have repeated your experiments, and indeed I observed convulsions. But are you sure that the origin of electricity is a frog muscle? I believe that this is a bimetallic arc which produces electricity, and the muscle of frog is just very sensitive electroscope." So he repeated experiments, but he gives completely different explanation. And this fact became the basis for every one of us use the discovery of Volta. The electric cars, everything where you use the batteries is due to Volta. He recognized that you have the two different metals and the frog's muscle is nothing else as an exit media. So he constructed his Volta column, and it became nothing changed, only materials, but ideology is of Volta. So this knows almost everyone. But what is interesting is that in our archive, even in the internet, you can find scanned documents that in okay, this I already told. Yes, so here you can read, cosa mai vi è qui che intende elettricità animale? Vale a dire propria e originaria degli organi, e non è anzi più probabile che siano essi meramente passivi, semplici elettrometri molto sensibili. So this is taken directly. Here you can find in our academy. But there is another letter. There is a letter to Abbe Vassalli from the February of 1794. And this is much less famous. But here, he repeated the experiments of Galvani not with bimetallic arc, but with iron arc. So he connected muscle of frog with just piece of iron and put one extreme in ice and another in boiling water. And he observed convulsions. So you see that this is evident thermoelectric effect, because due to the temperature difference, the electrons in metal move from the side where it is hot to cold. You have non-homogeneous distribution of the density of carriers, which means that you create electric field. Electric field, so the voltage difference at the extremes. But this fact passed not very observed. And you see, Volta was, okay, he collected respect and glory due to his battery. You see a famous picture when he presents his battery to Napoleon. Our academy was created. He became first president, etc., etc. But past 27 years. But a little bit before, let's go to Germany, and better to Eastland. In Eastland was born Thomas Johann Seebeck. He was born in modern Estonia. It was one of the countries of Germany, and he went to Germany to study medicine. But at some moment he had very good professor of physics, and he changed mind. He became physicist, and he then getting louder, he went to Jena. And in Jena was the Goethe, the author of Faust. And all of us know, me at least, Goethe as a politician and the author of Faust. I have even 10 volumes in my library of Goethe, which I, sincerely speaking, besides Faust, I did not read anything else. Nevertheless, studying these questions, I found that Goethe pretended to be also a physicist. And he had the salon where he accepted every week scientists, young people, etc. of Vienna. It was a center of attraction, intellectual attraction. And young Seebeck became his assistant. And he even stopped Goethe to do too much mistakes when he published 2 volumes of the theory of colors, which contradicted to Newton physics. And, but Seebeck was in the shadow of Goethe. And it was 10 years in this way. He became friend of Hegel, another famous person, the philosopher Hegel, the father of dialectics. And at some moment after the Napoleon War, when he lost in Russia, the father-in-law of Seebeck lost his factory, and Seebeck had to study to think about money for his 6 children. And he applied for position in Göttingen. Rector of Göttingen University asked recommendation letter from Hegel, and Hegel wrote later that Seebeck is a good guy, but not a great physicist. This fact of negative recommendation letter became well known, and they quarreled. Goethe tried to make peace between them, but they quarreled, and fortunately for Seebeck, he left Jena and went to Berlin. And he was inspired by experiments of Ørsted. So he tried to repeat experiments of Ørsted on electromagnetism, studying the effect on magnetic arrow he created this circuit, and he had two dissimilar metals, one hot, another cold, and put in the center the magnetic arrow. And he found deviation. And he even called this effect as a magnetothermal effect. Then Ørsted knew about this. He came and he gave the correct name, that this is thermoelectric effect. So what is the sense of it? Actually, when you put two different dissimilar metals in contact and put one extreme at temperature T1, another T2, so there is a redistribution in electrons in both of them, because the electrons prefer to stay where it's cold. But the reaction is different because the concentration of electrons is different. And due to this difference between two metals, you have current. So you can characterize it by the Seebeck coefficient, which is the ratio of the voltage difference, which will be measured in the, by the voltmeter, divided the difference of temperature which you applied. Very good. All is very good, but unfortunately, something, yes, okay, sorry. So this effect was measured, but still it was very weak. Anastas Pelletier, who was a watch dealer of Breguet, he was very precise person, and he, I'm afraid that I speak too detailed. Okay, so in any case, he found the inverse effect. So we know that if I apply gradient of temperature, so I have voltage difference. This is the Seebeck effect. But he found that if I will put in contact two different metals and the current will pass, so or heat will be released, or what is important, because Joule-Lenz effect, you always have heat release, because you have a product of square of current on resistance. So you always produce when you heat at home with electric ovens. But Pelletier effect is much more interesting because it depends on the sign. It is proportional to current. So you can release heat or you can absorb heat. And every time when you use your laptop, there is a Pelletier thermoelectric element which cool your your processor. So thermoelectricity found its how to explain it, how to find some formula now, because I just hand waving, but how to characterize it. Very simple. I can show you at the just level of school physics. So if I have, so what is chemical potential? Chemical potential is a price of ticket to enter in the system. So if in discotheque too much people, it costs more. If only a few girls, they can come free of charge. So in the conditions of equilibrium, chemical potential is the same at all points. But if I apply electric field, so I will have to speak about electrochemical potential. And electrochemical potential must be constant in the conditions of equilibrium. So the fact that electrochemical potential is constant means that its derivative is zero. So if I will do very simple calculations, I will show you that the Seebeck coefficient is proportional to the temperature derivative of chemical potential of your system. For metals, this derivative is very simple. It is ratio of temperature divided Fermi energy. So indeed, what measured Volta with frog muscle was 100 maximum microvolts per Kelvin. You multiply for 300 Kelvin our temperature of the room temperature, and you will find something negligible. Let's see. Please look. Seebeck coefficients in metals. So for all metals, you have microvolts per Kelvin. 47, maximum maybe 70 in some place, must be, I forget where. Yes, bismuth, minus 70. So multiply 300. Okay, in any case, working with metals, you cannot feed even telephone. So no chances. And we want, what are our tasks? For instance, to use the heat of muffler in your car, at least to use it for air conditioning, to return your how many of gas which you pay 1.8 per liter, so to return at minimum 1-2%, which in 1 year will give you 200-300 euros. How to do this? Okay, better situation with semiconductors, and semiconductors indeed work, but for instance, this effect is absolutely necessary to take into account in microelectronics, where the distribution of heat strongly depends on, for instance, in graphene, depends on temperature difference. The Seebeck is extremely important in new superconductors. We found that even in old superconductors, if you study it attentively, it is important. But all this is science. I will come to practice. So what means to have good thermoelectric material? Means that, so this means that energy provided to the load divided heat energy absorbed at hot junction must be acceptable to produce. This is the criterion of applicability. Maybe I will not, I have maybe 5 minutes only to finish.
Yes, 5 minutes.
Yes, so I will pass. So in 90s, people started to think about that we have to replace God and create new artificial materials. So the characteristic which is important is ZT. So you see that more Seebeck coefficient better, conductivity better, and heat conductivity is our enemy. So it is necessary to stop phonons. And people created new materials with special scatterers. These scatterers scatter phonons of different lengths. And you see that to have good applicability, factor ZT must be around 2-3. Today, we can arrive to 1.4. So it is a great progress in material science to use thermoelectric generators. We had this large project which our academy hosted in 2017. It was a large European project, Future Emergency Technologies, where we worked with complex fluids. So we have succeeded to increase the Seebeck coefficient 100 times in comparison with metals. Nevertheless, unfortunately, you have large Seebeck coefficient, but unfortunately also heat conductivity. And so result that they are not very applicable. Where are practical applications of thermoelectricity now? For instance, the Mars rover Perseverance carries a radioisotope power system. For instance, all the interstellar programs, of course, it is not enough solar energy which you can collect. So they use radioisotope thermoelectric materials. Finally, we can, as I already told, they are used in every laptop to cool the computer brain. There are some experimental models of BMW, and we work together with Fiat. And finally, some small Coke cooler, camping cooler, etc., which use Peltier effect. And okay, I do not have time for, okay, next. These are pictures from 2017, where the initial conference of this European project was organized, and you see people were impressed, and very grateful for hospitality. And finally, look, actually we use only 34%. 66 are lost. And even 1% to return would be a great deal. And we are going in this direction. And now several numbers. You can see how the thermoelectric generators market, how it increases with time. Not too much, only less than 1 billion per year. In comparison with superconductivity, where it is 10 times more. Or I do not want even to compare with semiconductor market, which is, the number is 772 billions. So nevertheless, we cannot thinking about sustainability, and we cannot ignore this field of science. It is developing. And finally, advantages. Solid state construction, no moving part, no vibration, available 24 hours a day, no noise, etc. And disadvantages. Slow technology progression, requires a relatively constant heat source, low energy conversion, etc. Thank you very much for your attention.